Welcome back to another episode of Freeform AI. My name is Michael Burke and I do data engineering and machine learning at Databricks. I'm joined by my co-host. His name is...
Ben Wilson. I work with this guy now at Databricks.
Yeah, it's the fucking best. For context, we're working on some internal tooling and Ben has lent a helping hand and it's so fun. Yeah, and this dude ships. I knew you shipped, but it's cool to see like firsthand. And we're going to be talking about exactly that. Basically, how to ship so that teammates can also ship. Often there's a lot of infrastructure that's required to create successful projects, not just the project itself, but sort of dev tooling and creating a culture of collaboration and ease. So kicking it off, Ben, let's give a little bit of background about this project. Basically, we're trying to build internal tooling so that the field, Databricks field engineers, are more productive with AI. That's sort of the problem statement of literally every project that we work on these days. And first of all, just I'm curious, Ben, do you think this is a good initiative? Do you think this is a bad initiative? Do you think we're at that inflection point in AI where it's actually possible? Or beyond that inflection point? What are your thoughts?
I think it's brilliant, man. Like, this is like what Gen AI in a corporate environment can do when like thought through and built with care. You basically build an interface that can do all of the stuff that it's not that humans are incapable of. It's that it takes so long to do these sorts of things. You've got facts and state of the universe information in 27 different systems, all of which have differing UIs, differing UXs, just finding stuff. Some of it is, I got to search through Slack, and then I got to go look at a bunch of documents that people prepared last year that explain this, like these series of features. Then I got to go and look in the docs. Oh, I need to look at docs in a different platform. Oh, I need to like just go and find all this information and then mentally distill it and then copy paste a bunch of links. And it's so tedious and monotonous. It's great if you're somebody who's got an eidetic memory and you know exactly where to go. But for the other 99.9% of humans, you don't do that. You got to like look up stuff. And it's particularly hard when some potential customer or an existing customer is asking about a feature that exists on your platform that you've never even heard of. So it's like, you got to go do like first principles research, like figure out where do I even find this information? It sucks, man. Like I feel that pain of all these people that have to do that. So why not just point a pretty smart LLM at all of this information? And then you can just ask it the question and in about 30 seconds to a minute, you've just shaved off 3 hours of frustration.
Yeah, well said. Let me rapid fire buzzword questions at you. Question number one. Isn't this going to take my job?
No, it's going to allow you to do the thing about your job that you actually enjoy. Unless you really like being like a corporate librarian, then yeah, maybe this isn't the tool for you.
Okay. That makes me feel a little bit better about my place in the workplace. Second question, why don't we just buy this? There's this tool called Glean. There's a bunch of other systems out there, a bunch of startups that are working on augmenting the workforce. Why are we building it?
Excellent question. We're a platform company that provides the tools in order to build these sorts of things. Psychologically, it's a little embarrassing if you buy something like this and you have the tools to build it yourself. That's one aspect. The other aspect is you get to actually use this stuff and find all of the cracks in the system because you're building something faux real that people care about and need to use. So you have to build it for real. And during that process, you start realizing like, hang on, this actually could be improved in some way. I can just send a Slack message to the engineering team that owns this and let them know, like, this is why this is painful. So it's invaluable from a dog fooding perspective because engineering doesn't do this. There's no time to sit out there and there's not even a skill set for that. You know, if you're a platform engineer, you're not somebody who's building super complex Gen AI systems. You're building the tools that allow people to do that. So it's a completely different skill set. And also they just wouldn't have time to do it anyway. So the people that do know how to do this stuff are the people in the field at Databricks because they're helping customers out. So let them build it and
Yeah.
see what comes out of it.
Yeah, it's been really fun because like we build a lot of applied solutions, and software engineering at Databricks is a little bit more abstracted and less focus on tangibly solving problems. You build abstract frameworks that can be applied to solve the problems. So field engineers are actually well equipped to be building these tools, and also, as you said, it's a great product feedback loop. I remember with Delta Live Tables, which is basically a data engineering ETL solution at Databricks, when it first released, it was broken to high heaven and stayed broken to high heaven for years. And then once we started using it internally, all the bugs just disappeared.
Yup.
So I'm hoping that we'll get a similar set of functionality for our agentic systems. Because, yeah, it's still cutting edge and beta, but this space is moving so fast that you want to pressure test it as much as you can.
Exactly.
Cool. So we're building this, we're not buying it. It's not going to take my job, even though I'm still illogically worried about it, but we'll proceed. So, Ben, I'm curious. We've assembled basically a dream team within the field. It's a very amazing privilege to be working with a lot of these people. And I know you came in and a few weeks ago were commenting that the morale was a little bit low. So, why do you think that is? And what have you been doing to change that?
It's not so much, it wasn't like everybody's demoralized and we have like everything's on fire. I think it was a product of the time that I first saw it while people were trying to like wrap their heads around effectively what the project was, from what I understand, and correct me if I'm wrong. There were a bunch of people who were part-time contributing to an initiative. And what they were doing is getting assigned different components of this. Like, hey, could you go build this thing that eventually will become part of this greater ecosystem? So they went in and built prototypes that they functionally worked to a certain degree, but they were basically just prototypes. It wasn't approached from the perspective of, oh, we're going to actually build a product here. So in order to move fast and demonstrate that, hey, we have something that you can go into a single UI and use all of these disparate tools, the implementations were built in silos. And then the final product state that it was in was, let's just glue all of this together in the same repo and then have a UI that'll actually render this so that there's an interface. So I think when I first started looking at it, people were like, what's actually in here? What do we need to do in order to make this more stable and more usable, and start working on hill climbing quality of these different tools? So what I first saw was like, oh, everybody is like really stressed out right now with like this mountain of work. But the project leads that had been planning it out, they kind of broke it down into, what do we immediately need to get done for an alpha release? And how do we show incremental improvements until we hit that alpha release so that we can demonstrate that like the resources being devoted to this are actually making this better. But when you're in the process of doing that and you're not privy to what that planning and what the Pareto level of, here's what needs to get fixed in what order, it can just seem like, hang on, I have access to the repo, but no, there's so much stuff to do. And you start seeing patterns of like, okay, there's duplicated code, or not duplicated exact code, it's not copy pasted. It's just like people in isolation who are not super familiar with the best practices on using APIs. They could, like, one person could build a very simplistic implementation that just doesn't have the required number of features. It's kind of like a true prototype. That's fine. And then you look at the other implementation and it's like massively over-engineered and super complicated. And you're like, okay, we don't need all of this stuff. And this is just making this slower and like the quality suffer because of how it's done. So I think what I witnessed was a lot of people just feeling overwhelmed at looking at the state of that. Correct me if I'm wrong. I don't know how you were taking it.
No, well said. I think that there's a lot of urgency around this project and a lot of pressure. And so people were really trying to get a lot of functionality out without having standardized dev practices. And that's just like a recipe for failure. But yeah, I think I completely agree. There was one case study that I think was it's actually stuck with me oddly a lot, which was someone had, and this happens literally all the time. It's happened, I don't know, 4 times in the past week, or not the past week, but 4 times the prior week because we didn't have dev practices set up and branch protections. But there were some PRs that overwrote prior code that led to breaks. And Ben, this happened with some of your code a few days ago, you mentioned. And what did you do? I thought it was actually really, really smart. Can you sort of walk through the meta thinking behind why you did what you did?
Yeah, so I filed this PR that was basically adding new functionality for one of the chat interfaces to store session state history. So like as you're typing and communicating with this agentic system, if you clicked on refresh or navigated away from the page to another part of the app, when you came back, you just have this fresh chat session. So you lose that whole history. So what I implemented was basically that history, that storage, so stateful, interface within the UI. It already was being written to, depending on the agent, it was being written to different places and different data structures and different architecture of doing it. So all I did was like standardize those on Postgres and created new routes so that the UI could actually display the data that was being stored in Lakebase, in like the Postgres database. So large PR, fairly complex, like number of changes, and merged it at like, I think it was like 11:30 p.m. because we wanted to demo it the next morning. And it gets merged. We verify, we look in the dev build, and we're like, sweet, it works. Good luck on the demo and stuff. And I don't know what triggered this, but I woke up in the morning and the first thing I did was come in, log in. This is like as my kids were getting up for like school. And I just fired off a personal dev build and just to make sure, because I knew that like the demo was going to happen like 4 hours later and things deploy. I go and check it and I'm like, oh no, why isn't the session history showing up? And I go and look in the main branch and I'm like, oh, the routes are gone. It's weird. And it was like, oh, somebody had to make changes to the backend Python layer and they're merged into main. They made a mistake. Like this happens all the time. And my immediate reaction is file fix PR immediately. But as part of that file fix PR, I created a series of unit tests for the back end that were just saying, if a feature exists, the route has to exist. So just like a one-to-one mapping. If a new feature adds, the test is going to fail, which lets you know I have to update the test with my new thing that I'm creating. And it's just protection. It's just like to prevent this from happening again, which is an honest mistake. And then filed the PR, got somebody to approve it. We merged it, did a test deploy. Everything's golden. Demo on stage works fine. But what I didn't do was raise holy hell in the dev channel or go to that original PR that broke what I had done and leave some nasty comment or try to calibrate somebody or even hit somebody up in chat to be like, what are you doing? You broke this. None of that is constructive. That's engineering behavior. That is exactly what happens in a professional engineering environment. And I hate it. It's just demoralizing to somebody. It's disciplinary action from a more senior person, which reads as a threat and hostile. What's easier to do? Fix the root cause so that like accidents can't happen anymore and move on. Make the system more stable so that other people can't make that same mistake, and then move on to the next thing. Like immediately start your next PR, the next thing you're going to be working on.
So this is fascinating, and this I think is born out of the postmortem culture at Databricks Engineering. So I'm curious for an example on that. But my naive brain is, first of all, I'm super mad. What the fuck? I send a Slack. That's like what I would want to do. But I would take a step back, be like, what's actually the true solution to this potentially systematic issue? All right, I write unit tests, and now that specific thing that happened can never happen again within reason. Like someone would have to disable the unit tests. My question to you is, do you think that that person, and I've made this mistake a million times, it's not a big deal, or it's like semi a big deal, but it's not uncommon. Do you think this person should be aware of that mistake and know to not do it in the future? Or do you think just writing the unit tests are sufficient and the sort of helping each other out, culture will disseminate through and eventually get back to that person so that they have better merge practices. Like, how do you think about changing the human behavior, not just fixing that one issue for the future?
The way to change human behavior like that is just to make the unit test exist. Like the next time that person does something like that and a test blows up, they learn their lesson. The system told them, not a human.
But you don't
That's
have
the key.
perfect test coverage, right? So what about some other part of the code base?
The world's an imperfect place, man. I'm going to mess it up next time. Like I've already messed stuff up. Last night, 9:55 p.m., getting ready to deploy a new version of prod, I broke one of the agents. Like it just would not render on screen. It was CSP violation. So it basically, I introduced a middleware layer to the app to prevent XSS and basically like embedding an iframe that shouldn't be there, which is like an attack vector. It's an internal tool. Nobody's going to do that, hopefully, but we should have security. And me and the project lead were talking, and we were like, yeah, let's put in middleware, just because it's safer. So I did that, and I made it too strong, so it disabled the ability for what they were doing in the app. Got a message from one of the project leads who was like, hey, I'm just testing this out and getting ready to try to do a prod deploy, and this doesn't render. I think all we need to do is just add this thing. And I'm like, oh my God, I'm so sorry. I had a feeling I would break something. Let me file a fixed PR real quick. Within 3 minutes, we had it fixed and the deployment was working. So I make mistakes all the time. The important thing is to let people know that I messed up. Sorry for that. But immediately after that is I'm fixing it right now. And in part of that fixing, if you can, introduce stuff that you or others can't make that same mistake in the future. Because it seems if you did it, or if you notice that somebody else did it, it's probably a common thing to mess up. So put in protections.
Yeah, so this makes a ton of sense, having like improving the dev flow of your team. There's often infrastructure around that, and also deciding what exactly you build is really relevant as well. So just fully taking a step back, you don't ever need tests in theory. If you write perfect code, we're good to go. But we're all human. We will all make mistakes. And so that's what tests are for. Unit tests are for discrete pieces of logic to catch things early. Integration tests are more end-to-end types of tests. And then you often have a dev or staging deployment where you can actually test the entire system live on real data. So that's why all those things exist. And deciding what to test and what to build is born out of your anticipation of what errors will be. That said, retroactively fixing things when errors do arise is probably the best way to know what to prioritize. If someone does make this mistake, then it is an issue that needs to be addressed. Ben, have you ever seen systems that overdo this? They basically test too much.
Of course. Not so much at Databricks. I think engineering at Databricks is usually pretty good with being reasonable about testing. Like you test the things that are catastrophic, or, if anything, a lot of it's like under tested, and that's just due to like velocity. But I've seen code bases that people are chasing code coverage percentages, and they have restrictions that are like, we have to hit 98% code coverage. And you start seeing abstractions in the code to make it capable of being tested at that level. And then you look at the unit tests, and the unit test code is 30 times bigger than the actual source code for whatever you're building. And you look at how long CI takes to run. You're like, dude, this takes hours every time I file a PR to know if things work. And the system isn't that complicated. It makes sense if you're building a platform like Databricks, right? Like the actual platform itself, that full testing CI is probably going to take like the better part of a day to run 1.7 million tests. Even if it's in a massive distributed cluster, Kubernetes pods just firing on all cylinders, like understandable that something that complex is going to take that long. But if you're building I'm building my chat agent and, a React UI, and you go and look in the jest test for React. You're like, hang on, why are you simulating every possible interaction that a user will do? Just check that the page renders. Like, there's an actual compilation engine working here. It'll throw an error if you screwed up. Rely on that. Or doing back-end testing where you're like, well, in order to be, fully perfect here, we need pure functions everywhere for like complex chains of logic. So now your code, instead of being 8 functions in a module that's like 200 lines long, you now have 64 functions in a module that's 3,000 lines long. And then you've got 15,000 lines of unit tests running all the different permutations of what you could do. It's like, why? And a lot of times you'll start seeing tests in there that are basically testing the language's ability to do what it's supposed to do. You're testing somebody else's code for no reason. It's like, why?
Yeah,
Test the failure modes that are most likely. And when a new failure mode comes up, like somebody made a mistake, which it's going to happen every day in a shared code base, write a test for it. Prevent that from in the future. No need to make a big deal about it. Just protect each other.
Yeah. It's funny, we're actually, for the AI FDE team, Niall, who's one of our principals now, I guess, one of 2 principals, is working on a AI FDE playbook. And what this does is it outlines in 100 pages, like what is good code, what is bad code, how do you do stuff, what are best practices. And about 10 of those pages is dedicated to testing. Like, how do you run it? What do you test? How do you test it? And I was reviewing one of the contributions for that, and it's not as trivial as you'd think if you don't have experience. And that's what this deck is supposed to do. It's supposed to standardize and disseminate knowledge specifically to junior people who might have different practices or new hires who come from different cultures. So obviously, or maybe not obviously, you shouldn't test code that's already been tested by someone else, like Spark. It's an open source language. It probably has pretty good tests, probably better than you can write yourself. So trust the framework and choose a good one. Conversely, if you choose a like random GitHub project with no stars and no usage that has no tests, maybe you would want to test that functionality or just roll your own. Ben, do you have any other advice on the trade-off between writing a crap ton of tests and just assuming stuff will work?
I mean, it's also like the big trade-off is, are you touching code that is frequently touched? Are you touching code that is really hard to determine if there is a bug in it? Like, what is the blast radius of it? So if we're doing something, for instance, let's say we have a function that its only purpose is to replace hyphens with underscores. And it's used at basically an endpoint, like the last thing that would be done right before rendering or displayed to an end user. Do we need 8 tests to make sure that we do that correctly? No. You'll be able to determine if there's an issue with that almost instantly. But that same exact function, if it's run at the start of a call chain and there's logic depending on that being correct, where there's like follow-on things that are using this, and you can start branching logical chains in a myriad of complex ways that is really hard to track down, then you better have pretty good unit tests on that to make sure that that logic works flawlessly, or as much as your brain can conceptualize how could this potentially go wrong. Because there's a huge follow-on blast radius to it, it can create really hard to debug issues. But if it's at the end of the chain and it's like, my eyeballs can determine very quickly if there's an issue here, maybe just a single test is fine.
Right. That makes perfect sense. Okay, cool. So the other thing that I wanted to chat about on this topic is going back to that merge issue and where you wrote a bunch of tests to prevent that from happening in the future. Databricks engineering has a very interesting post-mortem culture. So do you mind sharing one of the many stories where you broke something and had to write a post-mortem?
We actually call them no mortems because the whole point, like the historical context of a post-mortem is like a blame fest. It's like punishment. No mortems are still punishment because it saps a lot of your time. You have to write a lot of documents. You have to do follow-up work, but it's all meant to be a learning experience, and it's supposed to make the product more resilient. So the goal is identify the root cause of how this happened, but it comes from a point of Michael screwed this up. Like your name is not even mentioned in it. It's human screwed this up, developer screwed this up, but it's more from this. It's not, the blame is placed on the system, not protecting human error. And that's how you should think about it. It's not, oh, somebody like isn't doing their job, like they suck. That is nowhere in the equation. Now, poor management might actually attribute that, be like, oh, this person screwed all these things up. I'm going to give them a crappy, review, and then I'll try to get them fired. That sort of nonsense happens with bad management. But with a healthy work environment and a good management chain, it just, that indication should expose that, like, okay, maybe this person was working on more complex stuff. Maybe they're stressed out, whatever. Like, mistakes happen all the time. What the energy should be focused on is the system protecting us. And we build that system. So that's why the follow-ups to these no mortem incidents are, go make this so this can't ever happen again. That's your goal. That could be something really simple, like I'm just going to add 5 or 6 unit tests. Cool, done, protected. Or it could be, this system architecture is so flawed in that it makes it very easy to mess this up. We need to change the architecture, or we need to change CI, or we need to add in integration tests because this is so dangerous. Because if you just miss one little detail, you can take prod down. And that's a lot of money if you're doing something like that. Some of the crazy, stupid stuff that I've done, there was one where I made a change in MLflow that made it so that you couldn't log like Spark models to MLflow across the board. Like, it just broke it. And the realization that we came to was, you can't even unit test this problem. It's not something that is testable in, like, within the confines of MLflow. So the follow on to that was, well, we need to spin up like an integration testing environment of like a prod workspace. That took 2 months to do that. Not working all day, every day, but getting the approvals, getting the budget, getting like setting up the AWS accounts, setting up auth permissions and RBAC on like data that's being used, and had to create scripts that generate synthetic data and run through an actual model training of one of these things and then save it. And, there's a lot of steps that were involved in doing all of that, and then automating that to run every day at like 1:37 a.m. and then setting up the reporting chain to make sure that the channel, like, it automatically files an ES ticket if something breaks. It's a lot of work, but it was necessary work to make the system protect us in the future. And after we built all of that, we never had an incident again like that. It fully prevented that. But if when you're doing like building that system, you build into it some sort of monitoring that can detect, hey, every time that this fires off as like, hey, there's a problem here, you just log that somewhere, keep a record of it. So then a year later, when you're like, okay, did our prevention actually do anything, or was this a massive waste of time? And you go and look at the logs and you're like, 17 instances of this protecting us, and my name's in there twice. Yeah, this works. Like, this is how you do it.
Hell yeah. That makes a lot of sense. So just reactively addressing issues with systems, that is very logical. I'm curious, in this repo, we were also talking earlier today about ease of development and potentially changing the potentially low morale to very excited morale, and people actually shipping really quickly with high quality results. What are some things that you think are relevant to the dev cycle that just improve quality of life?
It varies for me. I think I'm just at a point in my career that I don't care what I build. I don't care what part of code I'm working on. It doesn't matter. What I care about is the thing that I'm touching right now going to reduce people's frustration? And that's end users or my peers that are working on this with me. And the way that I determine that is I go in with a completely clean slate, open mind, and just try to work on something. And then I have a blank notepad open that every time that hear that voice in my head, it's like, God damn it. Why? And I'm not saying that out loud to anybody or not, and I'm not blaming whoever did it. It's me being annoyed by the system itself. I'm like, why is this so hard? So I just write that down as a note. I'm like, dear future me, fix this shit so that I don't get annoyed next time I have to do this. And I
Real
start
quick,
collecting that
sorry to
information.
interrupt. How do you think about people versus systems? Because you keep going back to blaming systems instead of people. People tend to blame people all the frickin' time. How do you see people as this fallible thing and the systems are actually the one to blame?
It's always the systems. It's always the systems.
Okay.
I don't walk into a coffee shop and order a coffee that sucks and go back up to the person that made it and be like, you are incompetent. You suck at life. That doesn't do anything. All you did was ruin somebody's like morning and afternoon, or maybe made them hate their job even more. That's not the problem. The problem is the company and their rules about how coffee is made. It's a fixable thing. So it's the system's fault. There are people that help build the system and control the system. They're not at fault either. They might not be aware that this is an outcome that can happen, but it's not that individual's person. They're operating within the confines of something that they probably don't want to do. That person at Pete's Coffee probably doesn't want to be making my freaking, venti freaking red eye. And I don't blame them. I'm not going to make their life worse.
All right, let's take this here. What about shooting someone in the head?
Shooting somebody in the head.
Is the person to blame or is the system to blame?
Both. Why does the person have access to a gun? Who controls that? The system does, the government. It's a fixable thing.
Okay. Can you elaborate though how
But when you're talking about truly immoral acts, there is a personal responsibility for that. That's not somebody operating within a system. There is a system that exists, and it's called our legal system. Everybody knows that is not legal, that is not moral to do. So somebody is breaking the rules of the system. Now, if you're intentionally doing that, even in software development, as you mentioned earlier, like, oh, and the only way around this is turn off unit tests. You're now no longer following the system. If you intentionally do that, you will see my anger actually directed at a human being publicly if somebody were to do this on that project. Like I would not be like, okay, benefit of the doubt. I would call them out by name in the public channel to make an example of like, this is not how we do this. Do not do this.
Okay.
Somebody merges to main. That's not possible anymore because we have rules enabled on the repo that the project lead did on like day one of taking it on. And it's like, this is how you do this. Like, just don't let people do this. The system can protect people from innocent or less than innocent mistakes,
Yeah, that's what
provided
I
that
think.
they behave.
That's a really good delineation between people's intentions and people just, I don't know, being overworked or working quickly and making like honest mistakes.
Yeah, they might just not know any better because they
Hmm.
don't have that history of knowing like how bad this can go. So don't blame that person. I don't ever get angry at ignorance. It's just a completely negative sum game. All I'm doing is stressing somebody out who now feels stupid and feels inadequate. I feel angry because I've let my cortisol levels spike to infinity. So now my judgment is compromised for the rest of the day because I got pissed off. That person is terrified of incurring wrath in the future. So their productivity is like a tenth of what it could be. But if you just protect everybody, make the system better, then nobody gets stressed out. People just want to keep working and they're going to hit that roadblock. Like when they do something wrong and now the system says you can't do that, they'll be like, okay, well, I'll just go and fix that. It's a
Yeah.
positive reinforcement cycle of like allowing somebody to do the right thing by just making the system be the thing that's impeding them, and then they'll adapt around that.
Yeah. And I think one of the really nuanced takes of this, or maybe not so nuanced, is systems scale. Humans don't. So as you look to basically make the biggest impact on a given project, If you create a system that can scale to 1, 10, 100 contributors, that is well beyond what you could do as an individual contributor yourself. So if you're looking to make the biggest impact and actually help the team the most, creating systems that scale is the best way to do that.
Yeah. And never underestimate the power of holding back your frustrations from a public venue. Like, even if you're an immediate knee jerk reaction, and I don't have this anymore. I used to many, many years ago, but it's been beaten out of me working in very high pressure, software stacks. If you just internalize the frustration, let it go instantly, and then redirect that to the system, the reduction in group stress is incalculable in how positive that can be. If everybody's like, man, everybody's like nice to each other and like super chill and just collaborative, you are activating a part of the human mind in that group where people are enthusiastic about contributions. And if you set the stage of like, it's fine to make mistakes, like, we're not going to kill somebody here if this like breaks. We can fix this. We can make the system not only fix the system, but we can make it so that the system can protect against that in the future. People now feel enabled to, like, it's okay to make mistakes. And that's the culture that you need in a high functioning collaborative environment. Remove the fear.
That makes a lot of sense. That's something that I'm super actively trying to change. Is I'm uh, definitely not a dick on projects, but I've been a little burnt out recently, so a little bit shorter than I would like to be. And like we're all just having fun, like hanging out, writing software, like, and that vibe is just so much more fun to work in. And so leading by example with that is really helpful, but also like checking your attitude and checking yourself is so essential. And that sequences into, I think, my final question for you, which is, all right, focus on systems makes a lot of sense. That is highly scalable and allows people to be fallible. But theoretically, this culture that you're looking to create here comes from you and it stays within your head, right? What is the best way to disseminate that culture so it spreads? Do you tell everyone? Do you lead by example? Some combination? How do you approach it?
I mean, it's a combination. If you come off as like telling people in a group setting that like this is the way, you now come off as like a preacher. And some people dig that. They love that. And they're like, oh, what a visionary. Other people are like, man, shut up, dude. Like, I don't care about your crap. So that never works because you're polarizing people. Either way that you go about that, you're having, let's say it's a 50-50 split of those two tribes. It's negative on both tribes, actually, if you're trying to establish a wholesome culture. For the people that don't want to listen to your bullshit in their mind, you've now tuned them out, or they're tuning you out from now on. They think that you're this egotistical, oh, this is the person who's trying to control me. So they're not going to listen anymore to anything that you say. The other tribe is the people that they're now worshiping you in a certain way. Like, you're now on a pedestal and you're a hero. So they're not allowed agency in that environment, which is the worst possible thing that you can do. I think that's even worse than the people who are like, yeah, fuck you. I don't want to listen to you. They at least could potentially come around eventually. But the people that put you on a pedestal, you can now, in their eyes, do no wrong, which is like the worst possible thing that you could do. So the key is do it quietly, show it as an example of like how you progressively make things better and why you're doing it. People will kind of connect the dots, and people are not stupid. They'll be like, huh, this is all of a sudden better. And it's not about who made it better. It's the process of it became better because a human, not that human, but a human wanted to make this better. And when people start seeing that, they want to emulate that. They're like, I want to be the person that makes it better, instead of the person that's just like, man, this code sucks. I would have built it so much better. It's like, okay, you have your opportunity to like fix it. So do it. But don't come at the Like when somebody's doing that, the important thing for them to model themselves after is, I'm not doing this so people can see how awesome I am. I'm doing this because it helps the rest of the team out. I'm doing this because it's making the thing that we're working on together better and easier to make better. That's the real key. And then if people come up to you and want to talk about like, dude, why are you doing all this? That's when you break out into a one-on-one discussion and you can start talking philosophy. And in a one-on-one discussion, people can start internalizing that or challenging that and be like, no, I don't buy that. And you're like, okay, why don't you buy that? What do you think is the better way? And you start just going through a discussion of what the other possibilities are. Do we do this from a tyrannical point of view? So what does that build in a team? Do we do this from, okay, there's a leadership council and they dictate how everybody does stuff. How's that going to scale 5 years from now? Would you rather have a bunch of peers working on something where there's like just intrinsic trust? And when something breaks, nobody freaks out and people are like, all right, let's go fix it. Let's move on. Let's make the system better. And let's keep jamming. It's just a more positive environment. It's like the place that I want to work. And I think most people who are not ego driven, they thrive in that situation.
Yeah. My current perspective on it, and completely agreed, is first and foremost, I want to be who I want to be, and I want to be good vibes. Like, I want to be the one that's like helping in a teammate. So irrespective of it having trickle down effect, that's how I want to operate. And then second, I'm someone who tests a lot of hypotheses just in my career and like wait a few months, see if it gets the result. If not, iterate and try a new strategy. One thing I've noticed is telling someone about culture gets the fastest short-term result if you want them to do something for a week, but it really freaking does not stick. The thing that actually sticks is you leading by example. You won't get results for several weeks sometimes or even months, but then a year down the road, you check in with that person and they have fully adopted it. So it depends upon your ROI and your timeline, but if you can take a little bit longer of a time horizon, that's by far the most effective solution, at least from my experience.
That's backed up by everything from ancient philosophy to modern psychology. What you just explained, that
Mm-hmm.
is the way to lead. And that's
Yeah.
every effective leader in history who's not trying to seize power and become like, I am God King on earth, but more like, I'm going to be your mentor, but I'm not going to tell you how to be. And I don't want you to be like me. I want you to be the best version of yourself. And I'm going to show you a way that gives you the environment where you can grow into that. That's effective leadership and effective mentoring.
Yeah.
But it's
And also,
never about the person who's doing that. Like you're kind of beating around this whole thing like, oh, once you came in and started doing this stuff, it's not me, man, at all. All I'm doing is just, I'm the sandpaper. That's all I'm doing. I'm like looking through stuff, I'm playing around with it, and I'm like, that's a rough edge that I know somebody's going to get cut on. Let me go and sand that down for them. It also helps me because I'm like, the next thing I do, I don't have to worry about that sharp edge anymore. And you just start slowly doing that. And then all of a sudden, people are just like, man, it's a joy to work on this. Or, man, I love working with this team. And you can create an environment with a group of people that they're just like, they're almost excited to start their workday. Not to work crap loads of hours. You shouldn't be doing that. You should be, you know, working a reasonable amount, doing some cool stuff, and then taking your evenings and your weekends to yourself for like personal growth or like relaxation, whatever you like to do, whatever's your jam, go do that. But when you're like showing up to work, if you have that like ultra positive mindset and you're like, man, everybody around me is doing like awesome stuff and they're letting me like contribute and everybody's valuing my contribution and we're all like doing this together, all of a sudden you make awesome stuff when you have a group of people thinking that way.
yeah, super well said. I think we're at about time. I will summarize. But this is a very timely episode and very topical, I think, for both of us. But lots of cool things discussed. First and foremost, rely on systems and blame systems, not people. and use those systems to enforce rules. For instance, tests are a really great way to ensure there's quality. The purpose of tests is to prevent errors, so please just use them. And when you're thinking about what to test versus not test, think about the blast radius of that functionality. If it were to break, what would happen? If it were to run fine, what would happen? And how big is the infrastructure lift to actually test that piece of software? Another thing that's really, really important is how you lead by example. One thing is just be a good teammate, be good vibes, like enjoy it. You're on this earth for 90, 100 years. Have fun. Don't get angry. Anger is really, really bad for team morale, and it also can decrease your productivity. And if instead you drop it and channel that energy into fixing the solution, that's often a lot more productive. Anything else, Ben?
No, man, perfect summary.
Cool. Until next time, it's been Michael Burke. I'm my co-host.
Ben Wilson.
And have a good day, everyone.
We'll catch you next time.